Way back when, computers didn't think like you and I do. They were more like super-fast filing cabinets. Their world was made of simple single items. Think about the very first graphical user interfaces, or GUIs. You had these little pictures on the screen called icons. One icon might look like a trash can. Another might look like a folder. These were not just decorations. They were the language the computer understood. Each icon represented a very specific command, a single straightforward task that the machine was built to perform. It was a one-to-one relationship. One click on one icon meant one specific action. When you double-clicked that folder icon, you weren't having a conversation with your computer. You were sending it a very direct order. The computer didn't know what a document was in the way we think of it. It just knew that this specific icon, this little picture of a manila folder, was linked to a command to open a list of files stored in a particular location on its hard drive. It was a system built on pure instruction. You point, you click, and the computer does its thing. No guessing, no interpretation, just a direct cause and effect that made these powerful machines accessible to everyone, not just programmers. This method of processing information was revolutionary for its time. It took the incredibly complex world of binary code, all those ones and zeros, and translated it into a visual language that people could easily grasp. Imagine trying to tell your computer to delete a file by typing a long string of code. It's possible, but it's not very user-friendly. The trash can icon changed all of that. It was a universal symbol for get rid of this. This simple, icon-based processing was a monumental leap forward, making computing a tool for the masses and setting the stage for everything that was to come. The beauty of this system was its simplicity and reliability. There was no ambiguity. The computer wasn't trying to guess what you wanted. It was waiting for a specific trigger to perform a pre-programmed task. Think of it like a light switch. You flip the switch up, the light turns on. You flip it down, the light turns off. Early computers processed information in much the same way. Each icon was a switch for a different function. This clear, unambiguous method laid the groundwork for how we interact with technology, creating a foundation of trust and understanding between humans and their amazing new digital tools. As computers got more powerful, they needed to handle more than just single clicks on icons. They had to start understanding more complex information. This is where the magic of electrical signals comes in. Inside every computer, you have billions of tiny little switches called transistors. These transistors can be either on or off, representing a 1 or a 0. This is the binary system, the fundamental language of all modern computers. By combining these ones and zeros in incredibly long strings, computers could suddenly represent much more complex ideas than a single icon ever could. It was a huge leap in thinking. Think about what happens when you type the letter A on your keyboard. You press the key, and an electrical signal is sent to the computer's central processing unit, or CPU. The computer doesn't see the letter A. Instead, it receives a specific pattern of electrical pulses, a binary code, like 01000001. The computer is designed to understand that this particular sequence of on and off signals means A. This system allows for an almost infinite number of combinations. Every key you press, every movement of your mouse, is translated into these electrical signals, which the computer processes at unbelievable speeds. This shift from simple commands to interpreting complex electrical inputs changed everything. Computers could now handle streams of information. They could process entire documents, play music, and display videos. Each note in a song or each pixel in a picture was just another piece of binary data, another pattern of electrical signals for the computer to read and act upon. This is how your computer can run a complicated video game, with graphics, sound, and user input all happening at once. It's a symphony of electrical signals, all managed and processed by the CPU, the computer's electronic brain. This electrical processing is happening all the time right now as you read this. Your screen is displaying these words because your computer is constantly processing signals that tell it which pixels to light up and in what color. When you scroll down the page, you're sending a new electrical signal that tells the computer to change the information being displayed. It's a non-stop, high-speed conversation happening in a language of electricity. This ability to interpret complex data streams, not just single commands, turned computers from simple tools into dynamic, multimedia machines that have become essential to our lives. Now, we are in an even more amazing era, the age of artificial intelligence, or AI. Computers are moving beyond just following pre-programmed instructions based on electrical signals. They are learning to think, predict, and respond in real time, almost like a human would. Instead of just taking an order, AI can understand the context behind your request. It uses complex algorithms and massive datasets to find patterns, make connections, and generate brand new, relevant answers on the spot. It's not just retrieving a file, it's creating a solution. Consider it. It's a profound change in information processing. When you ask a digital assistant like Siri or Alexa, "What's the weather like tomorrow?" it does something incredible. It doesn't just look for a file named weather. The AI processes your spoken words, understands the meaning and intent, and then accesses live data from weather services. It combines this information to give you a natural spoken answer. It can even understand follow-up questions like, "What about this weekend?" This is real-time processing at its finest. The AI is actively thinking, connecting new questions to previous ones to hold a conversation. It's a dynamic, interactive exchange. This ability comes from something called machine learning. Scientists train these AI models by feeding them gigantic amounts of information: books, articles, websites, images, you name it. The AI learns the relationships between words, concepts, and ideas from this data. So when you ask it to write a poem about space, it's not copying a poem from a file. It is using its learned understanding of poetry and space to generate a completely new piece of writing, just for you. It's a creative partner, not just a calculator. This is a fundamental shift from processing what is, to creating what could be. This real-time, AI-driven processing is what allows for things like instant language translation or self-driving cars. A self-driving car's AI has to process a constant stream of information from cameras and sensors, other cars, pedestrians, traffic lights, and make split-second decisions. It's not following a simple set of icon-based rules. It is actively interpreting a complex, ever-changing environment and responding intelligently. This evolution from simple icons to complex signals to intelligent real-time answers represents one of the most significant advancements in the history of technology. Consider the science. So, what does this incredible journey from simple icons to brilliant AI mean for you and me today? It means our world is more connected, more efficient, and more accessible than ever before. Think about how you find information. Years ago, you might have had to go to a library and search through a card catalogue. Then, you could type keywords into a search engine. Now, you can simply ask your phone a complex question in plain language and get a direct, intelligent answer. This saves us time and empowers us with knowledge at our fingertips, making learning and discovery easier for everyone. This evolution has also revolutionized fields like medicine and science. Doctors can use AI to analyze medical images, like X-rays and MRIs, to spot diseases earlier and more accurately than the human eye alone. Scientists can use AI-powered systems to sift through massive datasets to find patterns that could lead to new discoveries, from developing new medicines to understanding climate change. The computer has evolved from a tool that organizes information to a partner that helps us understand the world in deeper and more meaningful ways. It's a tool for progress. On a daily basis, this technology makes our lives simpler and safer. When you use a navigation app on your phone, it's using AI to analyze live traffic data to find you the fastest route, saving you from sitting in a traffic jam. Your email service uses AI to filter out spam and protect you from phishing scams. Even your camera uses AI to automatically adjust its settings to take the perfect photo. These are not flashy, futuristic ideas. They are practical, helpful applications that are seamlessly integrated into our modern lives, working behind the scenes to make things better. Ultimately, the evolution of computer information processing, from basic icons to complex electrical signals to thinking AI, has supercharged human potential. It has broken down barriers to communication, education, and creation. We can now tackle bigger problems, explore more ambitious ideas, and connect with each other in ways that were once science fiction. The journey is far from over, but one thing is clear. As computers continue to evolve in how they process information, they will continue to provide us with amazing new tools to build a smarter, healthier, and more connected future for all of us.